Hello guys, welcome to this class. This is Nobleman Science Tutors Online, and for our class today we'll be discussing power. So if you have not subscribed to our channel, please subscribe to this channel. Click on the notification button so that whenever we upload a new video, YouTube will notify you. You can also reach us through the WhatsApp number that is showing directly on your screen. So please get your writing materials ready and get prepared for the class. So as I said, we are discussing power. So let's go straight to the class. Okay, sometimes as a student, you say, I have power and I have power and all that. So power is a common English that we use on a daily basis. So, but in physics, power is defined as the rate of doing work. Yes, the rate of doing work. So whenever you see rate, it means there's a time factor in the definition of power. So when you say rate, it means that there's a time factor in the definition of power. So the rate of energy expended is also known as power. The rate of energy expended, or the rate at which you do work. You know, when you say rate, then how much work can you do per time? Okay, so it is measured in watts, or the SI unit is joule per second. Joule per second, and it is also a scalar quantity. So 1 watt is equals to 1 joule per second, and 1 kilowatt is equals to 1000 watt, which is 10 raised to power 3 watt. So as I said, power is equals to work done or energy expended all over time taken. So this is the formula for power. Work done or energy expended all over time taken. Now we know that work done is equals to what? Force times distance. So power is equals to force times distance all over time. We also know that force times distance is equals to speed. So which means that speed or velocity. So which also means that power can be defined as force times velocity. So power can be defined as force times velocity. So depending on the question that you are giving, you can use any of this formula to find the power of a machine or of a body that is exerting energy. Then the efficiency of a machine is equals to power output all over the power input times 100 in percentage. So I want you to take note of these equations so that we can use them to solve some problems right away. So we are moving on to solve some problems right away. Okay, so this is the first question. An engine raises 100 kg of water through a height of 60 meters in 20 seconds. What is the power of the engine? This is actually a wire question, and I think it's an objective question. It is an objective question. So here you are giving mass of water to be equals to 100 kg. That's what you are giving. You are giving a height through which the water is raised to be 60 meters, and the time is given to you to be 20 seconds. Okay, so we also know that G is equals to 10 meters per second squared. That is your G. G is 10 meters per second squared. So power P is equals to what? Work done all over time taken, and work done is equals to what? Since it is raised through height, mgh all over time taken. Force times distance all over time taken. Alright, so what you need to do now is just to substitute your values. Substitute what you are giving. So you have 100 times 10 multiplied by 60 all over 20 seconds. So by the time you cancel all this out, you are going to have power to be equals to what? 33,000 watts, or 3,000 joules per second, as the case may be. 3,000 watt or 3,000 joule per second, or 3 kilowatts, as the case may be. So simply, this had to apply this formula. Is that okay? We'll solve another problem right away. So this is another question. The engine of a train produces a force of 3,018 when moving at 30 meters per second. Calculate the power of the engine. Remember that we said that power is equals to force times velocity. Okay, so this is your force and this is your velocity. So it's just a matter of you substituting these values, 3,000 times 30. So, and that gives you what? That gives you 90,000 watts, or 90,000 joule per second, as the case may be, or 90,000 joules per seconds, as the case may be. See, so once you understand the formula to use, sometimes it is very easy for you to solve your problems. It's just for you to understand the formula to use to solve a particular question, right? So we'll see solve another one. This one says that an electric water pump rated 1.5 kilowatt lifts 20 kg of water through a vertical height of 60 meters in 10 seconds. What is the efficiency of the pump? Okay, so we said that efficiency is equals to power output all over power input okay, all over power inputs. That is efficiency all over power input times 100 all over 1. You know, efficiency is expressed in percentage. Okay, so looking at what you are giving, okay, so the power rating of the machine is 1.5. So that is the power that the machine can put in to lift that 20 kg of water. So that 1.5 kilowatts is equals to the power input. So input power of the machine is equals to 1.5 kilowatts, and when you convert this to watt, you are going to have multiply this one by 1000, so that you have 1500 watts. Okay, so this is the power input. So what is the power output of this machine? The output power is the power that the machine can actually um, produce, right? The power that the machine can produce, so, or the electric pump can produce. So you have power is equals to work done in lifting this mass of water all over time taken. So that gives you the mass of water is equals to 200 kg. The height is given to us to be 6 meters, and the time is equals to 10 seconds. G is known to you to be 10 meters per second squared. So substitute that, you're going to have 200 times 10 times the height 6 all over the time. Time is equals to 10 seconds. So you can cancel this out so that your power will now be, your power output will now be equals to 1200 watts. 1000, when you work this out, you have 200 watt, 1200 watts. So now we have gotten the power output, then these are power inputs. So we can now solve that efficiency equals to output is 1200, inputs is equals to 1500 multiplied by 100 over 1. Okay, so by the time you work all this out, you are going to have that your efficiency of the machine will be equals to 80%. 80%. So this is how to use those formulas that we just discussed. Is that okay? So take note of this. Just take note of this equation and how to apply them, so that you can be able to solve any problem that you have on power, right? So this is your test your understanding page for what we have discussed so far. Please solve all these problems. Put your answers on the comment section, or you can put them on the WhatsApp number. Just add up that WhatsApp number, and then I will reach out to you if you have any challenge, so that we can see how I can be of help and assist you further in understanding physics. So also solve more problems from your textbooks, so that you have a deeper understanding. The more problems you solve, the more you understand. So please don't shy away from solving problems. Please solve more problems. Okay, so this is how we are, this way we are stopping our class for now. So guys, if you have not subscribed to our channel, please, I will encourage you, click on the subscribe button, click on the notification button, and then you can also reach us through the WhatsApp number that is showing right on your screen. Please give us a thumbs up if you like what we are doing. Give us a like, give us a thumbs up, give us positive comments. Also, you can invite your friends to come and enjoy what you are enjoying on YouTube. This is bringing physics direct to you in your homes. So it's something that we are working on. It's a project that we are still working on. So invite your friends so that they can come and enjoy this online physics class. Okay. So thank you so much for your time. We hope to see you in our next class. Thanks.